Hi, everybody. Good afternoon. Welcome to the Navigating Nature Inclusive Design, the Policy Perspective Living Windfarms Project Workshop. I'm just going to allow a few more minutes for anybody else to join, and then we can make a start. Okay, everybody, we've had a few more people join, so I'm going to make a start. Perhaps we'll have a few more people joining us shortly. As I say, welcome everybody to the Living Wind Farms Project Workshop, the Policy Perspective. Thank you all for joining. Um, Sorry, bear with me one moment. Could I just ask everybody to make sure their microphones are muted? Feel free to have your cameras on if you wish. There'll be an opportunity at the end to ask any questions that you might have. Before I get started, can everybody see my screen and hear me okay?
Yes.
Okay, perfect. So my name is Jack Catamole. I am Operations Manager here at Exo Engineering. And I just wanted to let you know as well, this session will be being recorded. So let's make a start. So just to cover what we will be talking about today in today's workshop, I will begin by briefly introducing the Living Wind Farms project before passing over to Pim Summers from the North Sea Foundation, who will be sharing some key considerations about decommissioning. After this, we will have a talk from Oscar from the Rich North Sea, who will be covering some of the latest research into benthic ecosystems and nature inclusive design. After that, we will hand over to Thijs from Total Energies in the Netherlands, and Thijs will share some considerations for successful collaboration, policy factors influencing decision making, and the red tape around kind of deployment and decommissioning. And then after that, we will aim to conduct a SWOT analysis of different nature inclusive design concepts. And finally, we will finish up with an open discussion where people can ask any questions that they might have. And also feel free to ask any questions in the chat as we kind of move through this workshop, and we can come back to these at the end. So before we dive into the latest updates, from the Living Wind Farms project, I wanted to take us back to the reason for the project existing in the first place. So, as we know, the North Sea holds huge potential for offshore wind energy, and we've seen increasing amounts of wind farms being constructed, and many more sites and wind farms have been proposed in recent years. And in order to reduce the impact of erosion around offshore infrastructure, we need to have some form of scour protection. So this is typically in the form of rock armor or concrete scour protection. And where these materials have been introduced, we've noticed that there's some kind of reef effect for species that rely on hard substrate habitats. And this is particularly important given the loss of hard substrate habitats over the last 100 to 200 years. For example, the estimated 90% loss of oyster reefs in the North Sea. So that brings us on to the purpose of the Living Windfarms project, which is really focused on maximising the reef effect that's being observed around the hard substrate scour protection, which has been introduced alongside the construction of offshore wind farms. So we wanted to optimize the design of scour protection without compromising the functionality and anti-scour properties, which of course is the whole reason why this hard substrate is there in the first place. The Living Wind Farms project is part funded by the Offshore Winds Growth Partnership, and we've built a considerable network of project partners, including Total Energies in the Netherlands and the Rich North Sea, who we have joining us for the workshop today. So we're able to achieve the aims of the Living Wind Farms project by working through the technology readiness levels. So from researching low carbon and recycled materials, understanding the science behind habitat and biodiversity provision, through to testing at a lab scale, understanding deployment and cost-effective production at scale, and finally, pilot deployments in real-world settings. And throughout this process, engaging with industry and wider stakeholders to share knowledge and ideas is really important. And that's what we're hoping to do as part of this workshop. So what have we been able to develop as part of the project? We wanted to make our solutions compatible with conventional manufacture, transport and deployment methods because we didn't want to add further complexity to an already complex and time-consuming process. So without going into too much detail, we've developed a range of solutions, nature-inclusive solutions, such as our Exo reefs, our full pipe deployable reef spheres, which form part of the armor layer around turbine foundations. We've got our Exo mat, which is a nature-inclusive articulated concrete mattress for cable protection. We've got our Exo anchor, which is our kind of nature-inclusive sinker, which can create reefs as part of mooring systems. We've also got our Exo Rock, which is our nature-inclusive rock armor for landfall infrastructure protection. We've got our Exo Lodge, which is a purpose-built 4.5-ton standalone reef unit, which is specifically designed to target Atlantic cod and has a sole function of boosting biodiversity. And finally, we've got our Exo Hub, which is an oyster reef unit, which is designed to champion the ecosystem services provided by oysters, whilst also creating reef habitats. And to briefly go over some of our pilot deployments. So along the top row, we've got some images from our Celtic Sea deployment at the Marine Energy Test Area offshore sites, which is off the coast of Pembrokeshire in Wales. These were deployed in September 2023, and we recovered these units following an 18-month monitoring campaign, during which we used remotely operated vehicles, BRUV surveys and eDNA surveys as well, to compare baseline biodiversity with post-deployment biodiversity. And then along the bottom row, we have some photos from our North Sea pilot deployment in collaboration with Total Energies. And we've got 5 of our Exo Lodge reef units, which were installed in July 2024. We have some talks after this, which will go into a bit more detail. But I will now hand over to Pim Summers from the North Sea Foundation. He will talk to us a bit more about considerations for decommissioning.
Yes, thank you. I'll have to share my screen. Yes, thank you. Thanks for joining this session. So I'm Pim Somers. I'm project lead nature-friendly offshore energy at the North Sea Foundation. We are a Dutch environmental NGO. We are one of the mother organizations of the Rich North Sea program, which is a partner in the Living Windfarms Project. So Oscar will talk a bit more about the Rich North Sea in a bit. But I will talk a bit more about the decommissioning aspects of nature inclusive design. So decommissioning of renewable energy infrastructure is going to be a major challenge. There's not much experience, but we know that in the future there will be, well, already in the coming 25 years, as you can see in the graph, in the southern North Sea, there will be a huge increase in the amount of wind turbines that need to be decommissioned. So only even decommissioning all this infrastructure will already be a challenge. And we are now also including a lot of nature inclusive design with these wind turbines, so that also includes the challenge as well. Currently, there's no OSPAR regulations for decommissioning of renewable energy infrastructure. That isn't, sometimes people assume that the OSPAR 98.3 decision for disused installations also directly is valid for renewable energy infrastructure, but that's not directly the case. So most national regulations are following this complete removal obligation also for renewable energy infrastructure, but that's not really formed within this OSPAR regulations yet. So there's also still quite a lot of differences in interpretation of how do we approach this decommissioning? Do we allow leaving scour protection behind? Does it also need to be removed? Do we cut the monopiles, the bottom fixed monopiles, to only like a couple of meters under the seabed, or do we need to remove more? So there's a lot of different approaches currently. And in order to streamline this, there's now a task force in OSPAR being set up that I will talk about a bit more in later slides. But currently also these nature inclusive design solutions that are also, being researched in the Living Windfarms project, currently, at least within Dutch regulations, also fall within the same permit as the offshore wind turbine. So that means that also the same decommissioning obligation is there for the nature inclusive design for artificial reef units, for instance. To make the bridge to oil and gas, where decommissioning has been happening a lot longer, I'm not going to talk through all of this, but there's been a lot of discussions already on the topic of how do we approach decommissioning of offshore infrastructure. And well, you will be familiar with the Brent Spar protest in 1995 that eventually also led to the OSPAR decision in 1983 that came into force in 1999. But currently also there's more and more talks about needing to revise this decision and take a much more flexible case-by-case approach. Because currently this OSPAR decision really has a black and white approach in full removal. So it's really a clean seabed policy for oil and gas. And this is now also directly being translated for offshore renewables. But for yeah, for the oil and gas, there are some derogations for the large steel or concrete installations. So when removal is impractical or great risk for safety, then there are derogations possible in order to leave something behind. But there's very little room for that. And also the InSight program. So that's a research program currently, I think, championed by Howe Marine Consulting in the UK, which, well, also in their synthesis report of their second phase urged to revise the decision in order to go towards a more case-by-case approach to decommissioning. But for oil and gas, there's very little to no consideration of nature-inclusive design. So that's a clear difference with offshore renewable infrastructure. Obviously, there are examples outside of the OSPAR region, outside of the Oslo-Paris Convention, where rigs to reef are possible. So there are solutions, there are examples where you can actually leave or repurpose parts of the offshore infrastructure into reefs to benefit biodiversity. So we know examples in the Gulf of Mexico, or well, maybe I should say now the Gulf of America, but also in Malaysia and in other places. Wind farms, on the other hand, well, we are approaching it differently than we are doing with oil and gas. There's from the start much more attention for ecology and biodiversity. So as Jack already mentioned, there is this reef effect that we want to enhance even, or with nature inclusive design that are also well in for instance in Dutch offshore wind tenders also promoted through non-price tender criteria in order to promote extra effort in order to make to improve the ecosystem. So we really approach it as not only as infrastructure, but also something that create ecological value. So we are implementing all these nature-inclusive designs, these artificial reefs, but what is the definition within OSPAR? Within OSPAR, there are some key principles, or in the definition, that it's these artificial reefs are submerged structures mimicking a natural reef. They have to comply with several OSPAR Convention obligations, for instance, with environmental impact assessments. For the removal and decommissioning, there's not a very clear statement, but they must be designed for safe removal. There are monitoring needs, and there need to be clear liabilities and responsibilities for the removal in order to make sure that when damage happens, that there's clear responsibilities there. But they steer towards restoring the seabed, so that the clean seabed approach is also within this artificial reef guidelines of OSPAR, in order to also comply with the OSPAR pollution prevention and habitat restoration obligations. So they steer towards having to remove them after a while. But currently there's talks within OSPAR as well, as I already mentioned earlier, that on the removal or the decommissioning obligation of offshore wind energy, and as it also falls within this same permit, this also would influence the decommissioning of nature-inclusive designs that are being applied at these turbines. So we know that these decisions, we don't know if there will be a decision made or will be a guideline or something, but there's a task force set up that is led by Belgium and Sweden, that was formalized during the workshop in London last October. And they will already have their first task force meeting in December this year. And there's, well, almost all of the contracting parties of OSPAR are taking part. So Belgium, Sweden, Norway, Denmark, UK, Netherlands, and Germany is still thinking about joining. Also, the European Commission is part, but also good to know that also for you to maybe influence or have contact with civil society organizations or other organizations such as Wind Europe or Seas at Risk or the ESCA was about cables, I'm not sure, and ACOPS, the conservation of ocean. So there's multiple members that also are in this task force directly talking about this obligation. So this is already a long process that has been going on, and they are steering towards a decision in 2027. So really the next year, 2026, is also a moment to try and influence this decision making on decommissioning obligations, and that also falls together with the EU Nature Restoration Regulation. So you might be aware that in the EU there's a new regulation that needs to be adopted, and in September 2026 the national nature restoration plans need to be submitted to the European Commission. So there's a potential good crossover there in order to make sure that the nature inclusive design options can also be included in these nature restoration plans in order to have an exemption or a derogation under the decommissioning obligations for renewable energy infrastructure. Yeah, so there's, as I said, there was already a meeting on 9 October. There's multiple topics being discussed. It's not only, of course, the ecological considerations, but there's a lot more to consider when discussing decommissioning. And OSPAR, yeah, what they will synthesize is still up in the air. We don't know if it will be a guideline decision or something. So the type of instrument is still being discussed. It might fall under the review of the offshore renewable guidelines that were first published in 2008. So decommissioning might be an annex within this guidelines. So that would be a less strong instrument than, for instance, a decision that we have for oil and gas. The first ideas in the task force seem to go towards that full removal still be default, but then include more derogations in order to have partial decommissioning. So that's something, yeah, to consider. But I would say, from my perspective, that would not be a very good starting point for the discussion, because then there's not that much incentive for partial removal. But still, yeah, obviously you need to make sure that you're also addressing circularity issues and other types of interest or topics that relate to decommissioning. Well, the outlook, well, I think it's now a very valid, very relevant time to advocate for this partial decommissioning. And I think really linked towards effective nature inclusive design to this nature restoration regulation. So not only the European nature restoration law, but also maybe the Marine Net Gain in the UK, in order to make sure that it's also a link within regulations there. And I also just to finish, I want to say we at the North Sea Foundation are also collaborated on a project on this topic. So we have the Nature Friendly Decommissioning Project together with both oil and gas industry as offshore wind industry. So the Dutch Offshore Wind Association and also TenneT as TSO for the cables. We are really trying to have create evidence-based criteria to help the discussion in policy. So we're really also advocating towards policymakers, both the Dutch government as also the OSPAR task force that I mentioned earlier. So if you want to know more, please contact me. Yeah. To finish off, there were also two publications from last year from Natuur en Milieu, which is the other mother organization of the Rich North Sea program. So there's conditions for sustainable decommissioning of offshore wind turbines and towards sustainable decommissioning. So that also goes into these topics. So you can find more on the third website listed here. And the other report, the third report, is from the Offshore Coalition for Energy and Nature, which goes more into avoidance and minimization, which also highlights decommissioning as a key knowledge gap that we need to know more about in order to minimize our impact there. So thank you for your attention.
Thanks, Pim. That was great, and it'll be very interesting to see the results of the nature-friendly decommissioning project. Yeah, thanks again. Could I pass over to Oscar from the Original Sea, who will be delivering the next presentation?
Yeah, thanks you, Pim, for your contribution. Let me start sharing my screen. Yeah, let's see if this all works. So, hi everyone. My name is Oscar. I'm a project manager for the Regional Sea program. We are part of a program of a couple of Dutch NGOs seizing the opportunities of offshore wind farms to work on nature inclusive design and for nature projects. I would like to take you briefly through some of our projects, and also I would like to tell you some about some latest developments within nature inclusive projects within offshore wind farms. So yeah, let's dive in. These images you see here, maybe some of you would have already seen them before. But I think it's just really important to stress these images because they are like the only snapshot in history that we have about how nature looked like before. We are not really sure how the North Sea looked 100 years ago or longer. But yeah, well, based on some scientific research and some history information that we have, well, we know that native oyster reefs were once a pretty dominant feature in the shallow waters of the North Sea. And now these ecosystems are assessed to to be universally collapsed. So for us, it's really important to keep on repeating that in earlier times, in the times of our grandparents or older, we had habitats that we want to restore. The Dutch part of the North Sea used to be covered by oyster reefs for about 30%, and also sea mammals like whales used to be quite common. Yeah, and I think that the loss of these ecosystems, in my opinion, well, is not only morally a problem, but also a problem in terms of food security, nature, climate change, but also for regulations and safety. So if we want to be able to make use of the ecosystem services of the sea in the future, we need to work on nature restoration and sustainable use of the North Sea. Offshore wind farms, they can play a vital role here by offering space and substrate, and more importantly, the lack of other human activities such as bottom trawling. So in 2019, the Rich North Sea program started with the idea of using offshore wind farms for nature enhancement activities. And with this program, as an NGO, we are actively working together with the offshore sector, as these companies are vital for nature enhancement within offshore wind farms. We connect these partners with other important actors such as science and technology and government actors. And in multiple Dutch offshore wind farms, we started pilot projects. And now, 6 years later, we've done projects in and out of the water and have learned quite a lot. And I would like to share some highlights to inspire you for the rest of this session. So we have experimented with placing oysters both on substrate and also on structures within offshore wind farms. And we have monitored nature inclusive designs like water replenishment holes in monopiles. And we have used artificial reefs both in and outside wind farms to see how biodiversity developed. And yeah, we have seen that based on our experience, there always is a reef effect, but it really differs per measure. But we do have learned that there are opportunities for nature within the renewable energy transition. And pilot projects and learning by doing approach, they give us insight into the possibilities of nature enhancement. And they also provide a lot of practical experience. And monitoring here is a prerequisite. And we will talk later in the session a bit about some monitoring results of the Living Windfarms project. Using ecological non-price tender criteria that stimulates innovation and also helps the development of knowledge. And nature enhancement needs to be laid down in laws and regulations. But we need to scale up because really nature enhancements, well, for that we need larger scales. But the projects that we have done, I just have some pictures here. You see an ROV where we have been monitoring. You see an oyster with a tracker so that we could see if it stays in place or it leaves. You see some bird structures that we have experience with. And with all of these projects, that they have shown us the willingness of stakeholders to work together, and also the possibility of nature restoration and nature inclusive design, and the potential for biodiversity. Projects that we are now developing are more focused on upscaling nature inclusive design, and we also have an ambition to work together with more international partners, also to start nature enhancement projects within offshore wind farms outside of the Dutch North Sea area. But before I tell you a bit more about some recent developments in nature inclusive design, I would like to briefly take you through why I think that, well, we still lack a focus, like a policy focus on nature. I think we should do way more, but there are just some big issues that holding us back to do more. First of all, I think there is a shifting baseline syndrome. I started this presentation with some very old pictures of the Dutch North Sea area. Well, I would love to go back to, I don't know, hundreds years or more to dive into that North Sea. But yeah, current policy is based on a baseline of, well, the recent North Sea. For instance, in Natura 2000 is based on 2000, which is already a degraded system. So yeah, it's always difficult. I very often get into discussions about, okay, to what North Sea do we want to go back? Like, do we want to restore the North Sea from 10 years ago or 100 years ago? Well, it's a very difficult discussion. I also like to stress the issue of multi-use. The North Sea is a very busy North Sea. And we want to do everything all at once: sand extraction, oil and gas, wind farms, recreation, fishing, transport. Well, I can go on with this. And the Dutch government decided to place wind farms, but we have to combine these areas with other purposes. But that is already in a very busy sea, and that means maybe more bottom disturbance and less room for nature developments. And also furthermore, our economy is based on money values, a bit of a capitalistic approach to all that we do, which makes nature very hard to fit in that system. People sometimes ask us what the business case of our project is, but in terms of, well, normal business case, there is none. Well, only a little bit. So that means that well, nature projects, they can also only take place when governments really ask or demand for it, because, well, the business case is pretty difficult. But that doesn't mean that there are no very interesting developments. I would like to tell you a bit more about a specific oyster project that we are currently working on, and also about a nature regeneration North Sea program, a new program in the Netherlands that is focusing on upscaling. So yeah, I would like to tell you a bit about that. I showed you some pictures of some of the pilot projects that we have. And before, we have experimented with broodstock structures on which we placed adult oysters. We have learned a lot from these projects, but, well, for actual reformation, we need hundreds of thousands of oysters. And it's almost impossible to reach that scale with adult oysters. It's also very expensive. When working with adult oysters and these broodstock structures, we have to place so many that is really expensive. And we have also some issues with, for instance, the decommissioning discussion that Pim just presented us about. But there's a new technique that we are working on with scientific and industrial partners, which is called remote setting of oyster larvae. The RESO project, it's called, it stands for remote setting of the flat oyster. Within this pilot project, larvae are raised in a hatchery environment, and then stones are placed in a container in the harbor. And these stones, they can be used for among others, scour protection or cable crossings. And then these larvae, they attach to these stones, and then the stones with oyster larvae can be placed on scour or cable protection areas. And this can be on a very large scale, as larvae are very tiny, so we can transport hundreds of thousands at once. This technique is still in the pilot phase, but if this really works, oyster restoration projects can reach a very large scale. So I'm very hopeful about these kinds of developments. Another interesting development is the nature inclusive, it's the Nature Regeneration North Sea program. This is a unique Dutch program founded by a combination of NGO, government companies, and also with scientific advice. And in this program, we are asking companies such as operators to participate. It is focused on an international scale, and the goal is to strengthen the North Sea nature with quite some money available, actually 150 million in subsidies till 2030. It's focused on learning by doing, upscaling, monitoring with an international perspective, the North Sea Basin, and also public communication. That is important for everyone to participate and to get the broader public to learn more about the North Sea. Within this program, and also with the subsidies that are part of it, we're now working on very large future NID projects for the next couple of years, among others on reef restoration projects. So yeah, thanks to these subsidy streams, I think big things are going to happen. This is the final slide I would like to share with you. We have developed an international, a toolbox where we have placed our projects, but also some other nature inclusive project within the North Sea. Not only with some scientific information and project results, but also very practical information for operators, but also for policymakers. So I would kindly invite you to visit the toolbox and, see if you can learn something from it. Yeah, thanks for your information, or for your attention. And if you have some questions, you can also put them in the chat if you wish. And I think I give the floor to Thijs.
Yes, I will take it from here. And I will be, first maybe let me introduce myself. I'm Thijs Kabel. I am the ecologist for TotalEnergies in the Netherlands. Today I will be presenting the monitoring results of our pilot at one of our gas platforms in the North Sea. But before I show the results, I will go through the policies that led to this decision to conduct a pilot at one of our platforms. And of course, the first one is a very important agreement that is made in the North Sea between all kinds of stakeholders in the Dutch North Sea about how we're going to achieve the three large transitions that will take place in the North Sea. It's about nature, food, and energy. Basically, all the different stakeholders came to agreement in this with this North Sea agreement. They signed it, and one of those things were agreed was that future energy infrastructure must implement nature inclusive design. And then we also see that back in the Dutch offshore wind tender regulations, where there are non-price criteria about ecology. And one of those is, for example, the implementation of a nature inclusive design of the scour protection. And then the site decision gives really specific requirements of the different type of solutions that you can implement. And they also have specific design requirements for artificial reefs and the Exo lozenges fulfilled those requirements. So that's why we were interested in testing those. And of course, we have our internal biodiversity commitments from TotalEnergies, and I think the main ones relevant for this pilot, of course, managing biodiversity at our existing sites and promoting biodiversity. But of course, we still have a few hurdles. I think one of the challenges is the permittability of NID solutions, because as was previously mentioned by Pim, the NID solutions are very tied to the permit of the energy infrastructure. It doesn't really matter if it's a wind turbine or a platform to inject carbon in an old gas field. If the NID solution is part of the infrastructure, then you don't need a separate permit, then it goes together with the permit for the infrastructure. But if you want to have something that is separate or not really connected to your infrastructure, then you need to apply for a separate permit. And I think can sometimes be good from a safety point of view. If you're within your 500-meter zone, then the risk of snagging by bottom trawler is good, but it also limits the opportunities to do something for nature, because you're quite limited that introduced into something what's part of your structure. And what I also noticed that when I was engaging with different Dutch government bodies, they have different views on nature inclusive design. I think it depends on what their task is. They have a different view, because some view it in a really positive way, and from others I get the impression that they see it in a negative light, and they see it as something that companies will use to skirt around their decommissioning obligations. So that's also something that I noticed, that different government bodies have a different view on nature inclusive design. And what I also see is that there is not yet a really clear defined definition of NID, and I think that sometimes leads a little bit to different expectations of what NID is or not. For some, nature inclusive design in the offshore context is the placement of artificial reefs, but some say even mitigation measures are part of nature inclusive design. For example, think a colored blade in a wind turbine, or adjusting the tip height so that certain marine birds can pass safely under the turbine blades. Some consider that nature inclusive design. What I also see is that sometimes I feel there's a bit blurred line between nature restoration and nature inclusive design, but that again turns back to your definition. If your definition is nature inclusive design is optimizing the reef effect of energy infrastructure, then it's slightly different if you want to use NID as a vehicle for nature restoration. So I think there it creates difference of expectation between different entities. And of course, what always remains a hot button issue, but was already excellently discussed by Pim, is the decommission aspect. And for our pilot, we will be decommissioning these artificial reefs when we're decommissioning this platform where they have been installed. So this is the background of policy decisions, what led to this pilot. So now we can discuss the results. And we first will start with the baseline survey. So we did this monitoring during our routine underwater inspections. Think of the inspections of pipeline, the jacket of the platform, to look for any technical issues. And we were able to tag on our monitoring scope to that scope of work. Now, what we see here is this is within the 500-meter zone of our gas platform at the location where the artificial reefs were installed. Of course, this is before installation, and we see quite a nice mixture of different fish species. So we see different kind of flat fishes. We see some dragonets. We also saw some mullets. We see some juvenile pounting swimming around, and we can see that the seabed is actually quite typical for that area. Sandy, not a lot of sand waves. And here we have quite a large lobster that lost one of his claws. So what we saw during the baseline, that we had a pretty typical fish diversity for this area. And we also had a look at the jacket at a similar height of that the artificial reefs have, to understand, okay, which marine species already grow here, which ones thrive here, so to understand what is the additional value of such an artificial reef, because this jacket has been in the water for around 30 years. So this is quite a mature marine growth community. And then we can understand after the end of this monitoring project, what is the added value of such a specifically designed structure? Does it bring does this additional investment bring any meanwhile biodiversity gain, or is a more simple structures already good enough to achieve an biodiversity? We see here different type of anemones. We see sponges, some different kind of tube worms. We see swimming crabs. So it's actually quite nice, diverse. And here we have, this is 1 year after installation, and here we can see one of these Exo lodges, the front view, and we see a lot of pouting, schooling around these artificial roofs, and that is actually quite a typical species that's associated with these type of artificial reefs. And there's also schooling between some whiting. But we did see during this survey that there was a little bit of a lower fish diversity in comparison to the baseline survey. We didn't see that many flatfish or any other typical more benthic fishes. We didn't see them during this survey. The baseline survey was taken in early August, and this footage was taken at the end of September. So that might be an explanatory for the difference in fish diversity. But you can see on this footage, we didn't use any bait to attract the fishes. We just let the ROV sink down and record. But we can see that the pouting really make use of this artificial unit. We see them swimming through the tunnel. You see them going through the side windows, and also marine growth developing inside the tube. And you can see on the outside, there's already some shell material accumulating, shells of different snail species. So you already see that there's some reef community developing. And here we have the top view, and you can see it's actually quite covered by edible crabs. And we were quite surprised that there were that many. And you can see they really like to sit in those crevices. I think it probably offers a safe space. And what you can see now in front view is the removable reef plug. So that is something that we can pull up with an ROV to study the marine growth in a lab. So this can then be preserved, and then a taxonomic specialist of marine growth can then determine the species growing on the reef plug. So that was a little bit of an innovative tool that we deployed to better understand the marine growth community on these units. We also put in, for this experiment, a control unit. So this is a simple Exo sinker. It's less fancy in design, and we want to see, do these Exo lodges were really quite specifically designed, big, complex? Are they worth the additional investment in comparison to such a simple structure? So by the end of the project, we hope to compare this control unit with the jacket, with the Exo lodges, and to get a better understanding, okay, what is now the additional value of this investment? Does it bring about a worthwhile biodiversity gain? And what I got also the impression that there is a little bit of larger marine growth on this control unit in comparison to the Exo lodges, but that might be explained to the amount of crabs living on the Exo lodges who can graze on the marine growth. And here you can see where we pulled up successfully the reef plug to let it analyze in the lab. And here we got the results. And I think the results were quite surprising to us, because we got a significantly large amount of species. These are about 40 species. And to put that into context, when we look in the North Sea environment at hard substrate samples, so scrape samples from hard substrate, the species richness varies between 20 and 60 species. And keeping in mind that these reefs have only been deployed for a little over 1 year. I think it's really quite good, quite impressive that we already got 40 species. Of course, it helps that we're so close to a platform that's already been in the water for 30 years, so that probably helps significantly in the biocolonization. But I still think it's quite impressive, and I want to highlight a few species. Of course, we had a high coverage of barnacles, which you could already see on the previous picture, but more than 500 individuals. And another important policy species that we got growing on this reef plug was the Sabellaria spinellosa. And Sabellaria spinellosa has been a focus species because it's one of the few species in the Dutch North Sea that can build reefy habitat in sandy areas. Research from the Dutch government has shown that those reefs are actually quite rich biodiversity hotspots. So when you take samples near Sabellaria reef, you see a real increase in abundance and diversity of species in the sediment. So that's why the species has been in such intense focus. And you also see the Dutch non-price criteria in ecology offshore wind tenders also include this species. So it's nice that we have it growing on our Exo lodges. And one other interesting observation was this. This was a little crab, and we found 700 of these individuals living on this reef plug. And to put that in perspective, this reef plug had a width of about 18 centimeters, and it was about 30 centimeters high. And there were 700 of these little crabs hiding in the marine growth. So for me, that is really quite an indication that this little ecosystem can be quite productive, because I can imagine that this little crab can be a nice food for many species. So I think this is really promising. Yeah. And for me, the main takeaways are that we were successfully to do this installation and monitoring during our yearly inspection campaigns. We saw a lot of pouting, congregating around the Exo lodges. For me, the real highlight was the retrieval of the reef plug. We were able to successfully collect the reef plug with the ROV, able to preserve it and get it in the lab in a good condition, and then found a really high species richness. And we also noticed both in small and big crabs, we noticed a large abundance of crabs. So that was it from my side. So now I will hand the microphone back to Jack for the SWOT analysis.
Fantastic. Thank you, Thijs. Yeah, great to see the underwater video results, and we look forward to the results of the further monitoring. Thank you, Pim and Oscar, for your presentations as well. As Thijs said, that leads us nicely on to the kind of interactive portion of today's session, where, as Thijs said, I would like to conduct a SWOT analysis. So what I hope to do with this is kind of evaluate 5 different types of nature inclusive designs, which we can use in offshore wind, to just kind of understand exactly what kind of strengths and weaknesses these offer in terms of nature restoration. We'll be evaluating nature inclusive turbine scour protection, nature inclusive cable scour mattresses, standalone artificial reefs, turbine add-on nurseries, and oyster restoration. And I think potentially one of the other slides used this nice diagram, but I think it visualizes it quite well, all the different nature inclusive interventions that we can kind of implement in an offshore wind farm. So what I invite you to do is join us on Mentimeter. So there's a couple of options for joining us over there. You can either head to the URL on the slide and enter the code, or alternatively on a smartphone you can scan the QR code. But I'll just give people a few moments to join us over on there, and then we can start the discussion. I'm just going to switch over my screen now to Mentimeter. I can see we've got 10 people that joined, so that's fantastic. Thank you for heading over to Mentimeter. I wanted to begin by asking whether people here have completed a SWOT analysis before. Fantastic. Everybody saying yes. Okay, that's great. Of course, SWOT analysis, we're looking at the strengths, weaknesses, opportunities, and threats of each different type of nature inclusive design that we can use within offshore wind. So as I mentioned, what I wanted to do at the beginning is to ask the audience if they could contribute strengths, weaknesses, opportunities, and threats in relation to nature inclusive turbine scour protection, this optimized nature inclusive scour protection layer. And rather than kind of breaking the SWOT into having one slide for strengths and one slide for weaknesses, I thought it'd be easiest to just group it together. So if you have a strength, weakness, opportunity, and threat, if you could just put kind of an S and a bracket or a colon or a dash or something just to kind of make it clear exactly what it is that you're contributing, that would be fantastic. So we've had a threat come in already, which is marine invasive species decommissioning. That's something that's been mentioned across the three sessions that we have. I think as Pim went into a lot of detail with, there's kind of a lot of discussion around exactly what we're going to do with these structures if we implement them, you know, at the end of the lifetime of a project and a structure. We've had a couple of strengths as well, opportunities for upscaling, supporting specific habitats like Atlantic cod, biodiversity gain, habitat creation. We've got a couple of opportunities and threats as well. One of the opportunities mentioned is replaces something that needs doing anyway. And one of the threats, barriers for inspection. I think that's a crucial consideration. We don't want to kind of impact on the functionality or the operation and maintenance of these structures. Another threat, more harm than good with removal. Linking in with the decommissioning again. An opportunity we've got here, policy requirements. And a few more strengths, modular, co-design with engineering function. Fantastic. Okay, I'll just allow a couple more moments and then I will move on to the next intervention type. Lots of opportunities coming in. Habitat connectivity, definitely, and standardization of monitoring methods between offshore wind farms with nature inclusive design scour. Fantastic. All right, I'll leave there and I'll move on to the next one. Thank you to everyone for the contributions on this. Now we invite you to contribute your thoughts on nature inclusive cable scour mattresses. So I suppose a little bit similar to the previous one, but the kind of enhanced articulated concrete mattresses that we use for cable protection. If you could contribute strengths, weaknesses, opportunities, and threats in the same way as on the previous slide, that would be fantastic. And after this, I've got a few questions that I hope will kind of begin a few discussions. I'd like to get your perspectives on those. Got somebody with a strength here. Dual functionality, yeah, kind of combining habitat provision with cable protection, of course. And a weakness as well, we've got limited scale. Another weakness, cable access restrictions. In a similar way to the last intervention, we need to, of course, be able to access cables if anything goes wrong. How do we do that if we've created a giant reef on top? That's something we definitely need to consider in relation to this approach. Got a couple of threats coming in now as well, not applicable for Dutch requirements/regulations. And seabed dynamics could lead to cover by sand. Yeah, I think it's really important to consider the substrate type that we're deploying these on. If we've got high current velocities, they might just get buried, and then we've spent all this time and effort designing a nature inclusive mattress that's covered up anyway. Potentially will not have the effects that we were hoping to see. A few more threats here as well. End of life complexity, decommissioning for maintenance. An opportunity here as well. Bioreceptive design innovation. And again, as before, I'll give a few more moments just for any last thoughts, and then I'll move on to some of the questions. Weakness, potential burial. Yeah. Another strength can be installed the same way as a standard mattress. Yeah, I think that's a key one if we want to make things as easy as possible. Use conventional deployment methods. All right, thank you, everybody. I'm a little bit conscious of the time, so I'm going to move on to the questions. So I've got a few statements here that I thought would be quite interesting to get the opinions of our attendees today. So feel free to kind of rank these, whether you agree with them, strongly agree, disagree. Hopefully everybody can see those okay. Fantastic, we've got some results coming in. I think it's worth mentioning as well. There's a pretty even split between the audience from the UK and from Europe. Our audience from the UK probably are aware of marine net gain, but for those dialing in from Europe, this is kind of an approach where we kind of attempt to put a monetary value on biodiversity by assessing habitat types, how significant a habitat is, kind of the ecosystem services that species or habitats provide as well. And I'll just give a few more moments.
Yeah, maybe it's just me, but I find it interesting that on the one hand, this group wants active policy from the government, but doesn't want it to be mandated. So it's interesting that everyone is in agreement that it's important, but it's not something that should be mandatory. And I find that interesting.
Yeah, thank you, Thijs. There's also quite a large split. The fourth question there, NID should never be mandated. There's quite a concentration around in agreement, whereas things like the third question, there's quite a split between opinions. So that's interesting to see. I will move on to the next slide now. Back to the SWOT, and this time we would love you to share your opinions on the strengths, weaknesses, opportunities, and threats for standalone units. So for those such as the ones in Thijs's videos from our North Sea deployment. kind of independent of the infrastructure around offshore wind. Fantastic. We've got a few responses coming through now. We've got a couple of weaknesses. Mass deployment is very expensive and difficult to reach large scales. I think they're two very crucial things we need to think about. Of course, something needs to be cost effective in relation to the biodiversity benefit as well. A few more weaknesses coming through. Lack of dual purpose makes financing them very difficult. And cost and spatial footprint. Limited control over colonization outcomes. We've also got some strengths. Can be deployed anywhere. And species-specific design is possible. Some of the opportunities that have been contributed more flexible, and when biodegradable, there are no issues with decom obligations. I think that's a really interesting point to consider as well. If we can create something biodegradable that kind of provides the basics for, say, natural reefs developing, can we create something biodegradable that just gives them the head start that they need and the encouragement, and then yeah, can biodegrade and leave behind a natural reef. We've got lots of opportunities coming through as well. Partnership building can be located in optimal places. Public communication and education. As before, I just give a few more moments for any last thoughts. One of the threats, decommissioning and conflicts with other sea users. Can be deployed in tourism spots. Yeah, that's a great opportunity. Okay, thank you, everybody. I will now move on to the next slide, where we want to get opinions on add-on units this time. So units that we fix to an offshore wind turbine, independent of the sea floor. I suppose that's one of the strengths. You might not need licenses and the same permissions as you would need for deploying something on the sea floor. And we've also got some more questions, which we hope will kind of invoke discussion after this. Brilliant, we've got some responses coming through now. As a weakness, difficult to monitor effectiveness. And a few threats as well, unintended consequences for structure stability / corrosion. I think that's a really important thing to consider when looking at this type of approach. The effect of drag and turbine fatigue, for example. An opportunity as well, can be fitted retrospectively and target specific species again. Target juvenile fish, supports fish of commercial importance. And a couple of weaknesses as well, biofouling of nursery units. I suppose if you're trying to keep your turbine clear of biofouling, but you're almost encouraging it in other ways, then that could be a bit of a tricky one to navigate. Can hamper monopile installation. One of the strengths, no additional seabed area required. We've got a few more opportunities as well. Spillover and add-ons can host sensors for research purposes. Yeah, that's a really good point. I'll just give a few more moments and then I'll move on to the next set of questions. Got three threats just come through: marine invasive species, operational interference, and additional risk for offshore operators, who are risk averse for a good reason. And finally, two more weaknesses: limited control over where settlement will occur, and only fitted to some turbines. Okay, thank you everybody. It's been really helpful. I'll move on to the next slide where we've got a few more questions. Same as before. To what extent do you agree with the following statements? It'd be great to hear your opinions on these. I just realised as well the first question is not worded correctly. It's meant to say despite incomplete evidence, I suppose. Of course, the evidence we have is not comprehensive about nature inclusive design. So just imagine that says despite incomplete evidence. Great. I've had quite a few responses on that one. I'll allow one more moment.
I think we will see within this group that is similar to decommissioning, that the want is to be optional where it makes sense. Same with leave in place decommissioning or partial decommissioning, to do it where it makes sense. So I guess this probably the same goes up for NID based on these results. But at least an overall opinion seems that people are positive about NID. So I think that's a good takeaway.
Yeah, definitely. I think we've got quite a concentration of answers around strongly disagree with the statement we shouldn't bother with NID, although somebody has answered kind of middle of the road, so perhaps they're slightly less favourable, but generally a consensus that NID is a good thing. Fantastic. Okay, I'll move on, and this is the last one. Oyster restoration. We would love to hear what you think the strengths are when looking into oyster restoration, and the weaknesses, opportunities, and threats. I suppose you've got the ecosystem services provided by oysters. That's a kind of strong incentive to look into that. We've had a strength come through: scalable, can be self-sustaining as one of the opportunities. Again, going back to the idea of kind of giving them the head start that they need. The brick in this photo is actually biodegradable, so that's kind of applying the same idea of giving them that head start and then allowing them to create a self-sustaining reef. We've got, as another strength, ecosystem engineer role, positive policy alignment. A few weaknesses coming through as well: larval supply limitation, parasites, a threat here as well, introducing disease to native oyster population. Fantastic, lots of responses coming through. I'll just give a few more moments for everybody to contribute anything else that they might have, and then we can move on to the open discussion. I've got a kind of question to end the interactive session on.
And maybe it's also good to share with the group what we will be doing with this SWOT analysis and of the previous workshops.
Yeah, of course. So we do intend to host a final kind of Living Windfarms Project workshop, where we hope to invite everybody who's attended from the different kind of perspectives, the ecology, the contractor, and yourselves, the policy perspective, to kind of have a discussion and bring together all these different ideas about nature inclusive design. And we will probably be doing this online. So if you don't follow us on LinkedIn already, that's the place to be to stay up to date. So feel free to follow us over there, and we'll be posting about that in due course as well. Thank you, everybody. I will move on to the next slide as a final question, and then we can open up the floor to discussion. And the question I wanted to ask people is, how can policies balance rapid offshore wind expansion to meet climate targets with the effort and time required for effective seascape scale NID? So I want to thank you all for completing that SWOT analysis with us, and we welcome any thoughts. Feel free to unmute yourselves and contribute if you wish.
Yeah, okay. For me, I don't think you, for looking at seascape scale, I don't think you should look at offshore wind operators. My opinion is that within offshore wind farms or gas platforms or CO2 injection platform, NID should be about optimizing the local reef effect to get more out of the fact that those offshore structures will function as an artificial reef. The reef effect has been proven effective, but I think it's not wise to look at that as for basin level ecosystem restoration. I think you should look at more into really protected areas, and I think offshore wind farm definitely can have a positive effect when you're looking at the reef effect. But I think if you want to look at seascape scale or sea basin scale, I think you should look more at real nature restoration in nature areas. But I think that's
yeah, I think that's a really interesting point to raise. I was wondering, just off your response there, Thijs, whether you think there's kind of design aspects that could be taken, for example, that could be kind of a blanket approach, if you will, and then we just kind of tweak specific different features to appeal to species in kind of more specific locations on a case-by-case basis.
Yeah, I think definitely if you're looking to apply NID with an offshore, you definitely should look at your local site, because the conditions can vary, especially when you're looking at research papers, is that the water depth and water conditions can be very more important determining factor for the species composition than your reef design. So I definitely think it's possible to make tailor-made designs. And for example, if you could indeed make oyster reefs in offshore wind farms work, and there is a nearby area that is designated as underwater nature restoration area, and you could have oyster spat moving from outside to the offshore, outside the wind farm to a nature area. I think that could be a win-win situation, especially if the broodstock came from local populations of native Dutch or whatever country you are. I think that would definitely be a win, and there I see the potential synergies.
Yeah, I have to say I do agree with Thijs that I think NIDs are not the solution for seascape scale nature restoration, or so definitely in order to work towards a healthy North Sea, I think we we definitely need to focus mostly on protected areas. But these are necessary contributions that that energy infrastructure can have in achieving this good environmental status. And I think that when planning nature inclusive design, that there should be, well, they are promoted, for instance, in the Netherlands, they are promoted in offshore wind tenders, as also presented in the presentations earlier. But these are very I think they can be substantiated a bit more from the potential in certain regions. Like if you tender a certain wind farm that is close to a very valuable ecological site, when there you need certain, you want to promote certain NIDs, and now it's a bit. It doesn't comes across as it is informed from the location, but more every tender round has an ecological tender in it, which is also good. But I think it would be better if it could be better considered on a regional scale. Where are the biggest opportunities for nature inclusive design, and where should we promote it more? Well, I think still also referring back to the questions in the Mentimeter, we should have everywhere a certain level of nature inclusive design, but the real wins should be more considered at locations where there's actually proven potential or links or connectivity to natural reefs, etc. So it could be a bit less opportunistic and a bit more substantiated from actual experience or research.
Yeah, I think you definitely make a valuable point. And I think you also see it in the Mentimeter results, that people are looking from guidance from the government to have a vision on NID, to have a vision on nature restoration. I think if there is a more global or local vision on the Dutch North Sea or the whole North Sea, I think that really could help to make these measures more effective.
Yeah.
And it was, of course, also always a bit contradictory. Is of course, at least in the Netherlands, the wind farm locations are selected to have the least amount of impact on the nature. So you pick areas where they expect the impact to be as minimal as possible. Of course, that are not, hopefully, not the areas with the most interesting biogenic reefs. So then it's always, of course, then if there are not such reefs in that environment, should we then focus on the restoration of reef forming species? So that's also something that makes it challenging.
No, I agree, but still there are obviously differences in wind farm potential for ecology. So still some locations have more potential because of their hydrodynamics or their depth or their certain characteristics. They are just more suitable. So even though they are not the most ecologically valuable locations, there are still differences between the different locations, obviously.
Yeah.
Fantastic. Have we got any more questions from the audience? Perhaps about the question that I asked to finish up on, or perhaps some of the other questions in the Mentimeter. Feel free to ask them.
And maybe a question for me for Exo Engineering. How do you take specific site information into your design consideration? So if you get the information about a site and you see the species list or these environmental conditions, how do you integrate that into your design? What is your philosophy or approach to that?
I think there's a difference between kind of coastal designs and kind of offshore designs. I think the Exo lodges were designed in accordance with specific design criteria from a Dutch offshore wind farm. So this was kind of evidence that had already been gathered as such. So I think it's important for kind of standardizing the approach without going so far as to kind of using a blanket approach. And we know, of course, for kind of mobile species, for example, Atlantic cod, which these solutions were trying to target, evidence exists already about the kind of shapes of the features and the size of the features that kind of benefit them, the habitat features that they like. But I think it's also depends on kind of the substrate type. There's no point if you know, the substrate is mud, putting down a big low carbon concrete hexagonal reef because it might sink, or you know, kind of full pipe deployable spheres. I think there's a lot to kind of consider with that.
Okay, now I think if there are no further questions, then Jack, you can wrap it up for today.
Yeah, of course. Well, thank you to everyone for joining the call today. Thank you to our presenters as well. As I mentioned, we plan to do a further final workshop where we kind of compare the contributions from the different audiences. So keep an eye out on LinkedIn, and we'll be posting about that in the near future. But yeah, thank you to everyone for contributing to the SWOT and for attending the session today.
All right, thanks everyone.
Thank you.
Thank you.
Thank you.
Thanks.